Hello, welcome to this video, lesson 2.2. We're in Unit 2 of Accelerated Math 3, and this video is for adding and subtracting rational expressions. I'm going to cover three ranges, well, actually really kind of two different topics for this lesson. The first video, which is going to be this video, will talk specifically about excluded values. Now, you guys have some knowledge of excluded values already in dealing with rational functions, right? And the idea is our denominator cannot be 0. We have a denominator of 0, we have a vertical asymptote there, so we kind of restrict those domain values. So we're kind of doing that same thing in this video. The videos after, the two videos, I'm going to split them. We're going to add and subtract rational expressions. We're going to work with lowest common denominators. And yeah, so let's get to it. We'll go ahead, I'll make myself smaller. Boop, there I am. Okay, and here is our first slide. So again, our objective is to add and subtract rational expressions, but first we're going to focus on excluded values. So the text here says a rational expression has the form p of x over q of x, where p of x and q of x are polynomials. Since there will be a variable in the denominator, a rational expression has excluded values. And again, this is what we were talking about here, right? Where our denominator, okay, cannot equal 0. Cannot equal 0. That is bad, right? Because we can't divide by 0. If we do, the world explodes and everything is just not right. Okay, so what we get is undefined values when we have a denominator of 0. Okay, so what are we going to do? Well, we are going to find what is called excluded values. Can you say that with me? Excluded. Okay, good. Now say excluded values. You're so good. Okay, excluded values. So to find the excluded values of a rational expression, you're going to find the values of the variable that make the denominator equal to 0. Okay, and this is exactly what we're going to do. So notice in this example here, I have a rational expression x plus 3 over x squared minus 5x minus 6. And to find the excluded values, all you do is you're going to take the denominator, you're going to set it equal to 0. You're going to factor. And we are going to go ahead and solve this expression. This is exactly what we did before when we were dealing with vertical asymptotes. How do you find your vertical asymptote? Set the denominator equal to 0. Exactly, okay? And our conclusion from this, the excluded values, we cannot have domain values 6 and negative 1. Okay, so kind of what we're doing here is we are restricting the domain. And we'll talk about the purpose of this later on, but simple enough idea, right? Let's get to it. Okay, so here are some examples, and please write these in your notes. And the first thing, again, that you want to do, kind of the algorithmic way of doing this, is you want to solve for when the denominator equals 0. So here's the denominator, 2x squared minus 5x minus 12, and I'm going to set it equal to 0. How do I solve this? Well, you got to factor. Factor. Okay, so I'm going to open up two binomials. We can factor by inspection, also known as guess and check. So I have 2x and x over here. And let's try 3 and 4. So I want a negative 5. Let's make that 4 negative. That gives us negative 8. And a positive 3. Does that give us negative 5? It does. Okay. So I want to solve this. Well, we're going to use the zero product property. So we have 2x plus 3 equals 0. Or x minus 4 equals 0. And now we're just going to use our algebra to go ahead and solve, right? Subtract 3. Divide by 2. Schwarberg, I know this. This is so easy, Schwarberg. I know you do. Good job. Okay, now we have to go ahead and solve for the other x, right? So I'll add 4 plus 4. I don't know where that voice came from, but it was there. Okay, so x equals negative 3/2 and x equals 4. I have Kevin in my class. Kevin, if you're watching this, negative 3 divided by 2, go. What is it in decimal form? Negative 1.5, that's right. Okay, so what's our conclusion? Our conclusion, and this is important here, we need to think about, like, why are we doing this? Because math. No, not because math. Our denominator cannot be these values. So x cannot equal negative 1.5. X cannot equal 4. Okay, if that's it. If that's easy. All right. Round 2. Okay, like the bell. Okay, so we're going to go ahead and solve for when x squared minus 36, yes, is equal to 0. So I'll factor x minus 6, x plus 6. That's what we call difference of squares. Equals 0. X plus 6 equals 0. And we solve again. Okay, so this is saying, okay, what values make the denominator 0? And we get 6 and negative 6. That's no bueno. We don't want 6 and negative 6 because then we are dividing by 0. The world explodes. Okay, so our conclusion, x cannot equal negative 6, comma, x cannot equal 6. These are restricted from our domain, thrown out. They're not cool enough to come hang out. Lo siento. All right, and then last but not least, this third example, wait, hold on. Okay, 3, right? 3 for third. Okay, this one's weird. Okay, again, I'm going to go ahead. I'm going to solve x squared plus 5. When does this equal 0? Let's investigate. So we're going to solve. I'll subtract 5 on each side, giving us x squared. I don't know why my computer keeps deleting that. We get x squared equals negative 5. At this point, you should think, like, what's going on here? Why do I have a squared value that's negative? That can't ever happen, right? And I'm glad you know that, but we're gonna do this anyway. Watch this. This is taboo. I'm taking the square root of a negative number. How dare you? X equals plus or minus the square root of 5, and when you have the square root of negative 1, that is I. Yes, I. Imaginary values. Okay, so I have imaginary restricted values. What does that mean? Well, it means there's no excluded values. I have no excluded values here. Okay, so no excluded values. Right? The domain of this expression would be all real numbers. Okay? Hey, that's it. That is excluded values. Plain and simple. Take the denominator, set it equals 0, solve. Okay? Anything that comes out as a solution, whoop, you throw it away. I have some practice problems right here for you. I would like you to try these. Please pause the video. Just checking to see if you paused it, okay? Pause it, and then I want you to solve these. I'm going to go ahead and show the solutions right about now. So hit pause if you have questions, write down questions, rewind if you need to go back. I believe in you. You can do this, okay? Pause. All right, now here are the solutions. For real, pause this time. There you go. Okay, so there are the excluded values. Again, in this video, now I'm big again. This video, we just talked about excluded values, restricted domains. Okay, these will come back in the future. I'm going to sign off now. The next 2 videos are going to focus on actually adding and subtracting rational expressions. Peace. Give me a thumbs up. Subscribe. Yeah.